Welcome to this explainer. Today, we are diving straight into the invisible mathematical mechanics of our world. We're looking at the fundamental science of waves, drawing directly from the Heroesmartacademy Godly Learners series. This curriculum presents a really fascinating perspective. It shows how measuring the physical universe actually helps us uncover the incredible design behind it all. We're going to break down how wave measurements work, why they matter to our everyday lives, and how this specific curriculum connects our scientific understanding to a much broader spiritual framework. To set the stage, let's take a look at the foundational philosophy of our source material. Psalm 147:5 states, "Great is our Lord and mighty in power. His understanding has no limit." The curriculum frames our entire study of physics right through this lens. Just as this verse suggests an infinite wisdom, understanding the incredibly precise, intricate measurements of waves opens up literally endless possibilities for us to explore the mechanics of creation. It's a great reminder that learning the how of the universe can actually be a deeply profound experience. Here's our quick roadmap for today. First, we'll look at the big picture in the infinite wave, followed by the physical definitions in anatomy of a wave. Then, we'll examine how these forces interact in the wave relationship, check out real-world wave power, and finally, unpack how the source material connects all of this to education with morality. All right, let's kick things off with Section 1, the infinite wave. You know, whenever energy travels through the universe, whether that's sunlight hitting your face, the bass thumping at a concert, or just ripples in a pond, it moves in waves. And to understand this energy, we need a way to measure it, right? Well, there are three critical measurements that describe a wave's cycles. We have amplitude, which dictates size, wavelength, which dictates length, and frequency, which dictates speed. Think of these three metrics as the essential measuring tape for all moving energy in our world. So what do those measurements actually mean? Let's get into Section 2, Anatomy of a Waves. First up is amplitude. In simple terms, this is the height of the wave from its resting position to its absolute peak, the crest, or all the way down to its lowest point, the trough. Imagine a perfectly still pond. When a ripple rolls through, the exact distance the water rises, well, that's the amplitude. The absolutely crucial takeaway here is energy. Higher amplitude means more energy. Just for context, the amplitude of a massive tsunami carries enough energy to literally reshape entire coastlines. Next, we've got wavelength. While amplitude measures up and down, wavelength measures side to side. It basically determines how stretched out a wave is. You measure it by finding the physical distance between two matching points on consecutive waves. Honestly, the easiest way to do this is just measuring from one crest directly to the next crest. If you have a really long wavelength, those waves are super stretched out. But if you have a short wavelength, they are packed tightly together. And that brings us to frequency. If you were to just stand still and count exactly how many waves pass you by in a single second, you'd be measuring the frequency. It's a vital metric for speed and timing. Now, because saying waves per second can get a little wordy, scientists use a specific unit of measurement for this, called hertz, abbreviated as Hz. So if 10 waves pass a point in 1 second, boom, that wave has a frequency of 10 hertz. But here's the thing, these measurements don't just exist in a vacuum. Let's move to Section 3, the wave relationship, to see how they mechanically interact with each other. The crucial point here is a mathematical inverse relationship. Basically, if the speed of a wave stays constant, when the wavelength increases, the frequency absolutely has to decrease, and vice versa. Think about long ocean swells for a second. Because they're so stretched out, fewer of them pass a given point per second. That gives them a low frequency, but it allows them to travel vast distances across the globe. Now contrast that with short ripples in a puddle. They pack tightly together and hit a point rapidly, meaning a high frequency, but they quickly lose their power and fade away. Let's transition into Section 4. Why does understanding this invisible math matter to humanity? Let's look at real-world wave power. The honest truth is, our entire modern world is built on mastering these exact measurements. Without understanding amplitude, wavelength, and frequency, engineers couldn't fine-tune the communication signals for our radios, TVs, or the fiber optic cables that deliver our high-speed internet. Doctors wouldn't be able to use high-frequency sound waves for medical ultrasounds, and oceanographers couldn't predict wave behavior to protect shipping lanes. These aren't just abstract textbook numbers, they're the literal tools we use to build, communicate, and protect ourselves. This invisible science impacts the physical world you interact with every single day. For instance, seismologists rely heavily on amplitude. Taller seismic waves on their monitors indicate a much more energetic, dangerous earthquake. In the realm of music, when you hear a piercing, high-pitched note, your ear is actually detecting a sound wave with a very high frequency and a really short wavelength. And out in the ocean, surfers know for sure that large amplitude waves carry the most energy, creating the hardest crashing surf. Okay, before we move on to the philosophical side of things, let's pause for a quick checkpoint just to see if we're on the same page. Based on the inverse relationship we just talked about, here's the question. If a wave gets stretched out so its wavelength increases, what exactly happens to its frequency, assuming the wave speed stays the same? Take a second, think about those long ocean swells. Got it? Yep, that's right. The frequency decreases. If you got that right, you have totally grasped the core science. And that brings us to our final section, applying this understanding to our morality as framed by the curriculum. Let's look at education with morality. The HeroesMart curriculum poses a really interesting challenge here. They teach that education, when separated from biblical morality, will ultimately hurt us. It's a pretty profound argument. What is the point of understanding the mechanics of the universe if we just continue to make harmful choices? Knowing wave science to build powerful technology is incredible, for sure, but the source argues that without a moral compass, our raw intelligence simply isn't enough to prevent us from causing pain. Instead, the curriculum advocates for deeply intertwining our scientific education with a spiritual foundation. Pointing to Romans 8:6-7, the text promises peace of mind to those who keep their minds spiritually focused. The overarching lesson presented here is that pairing a rigorous study of the physical universe with rooted morality actually transforms cold, hard data into a framework for true, lasting peace. So, as we wrap up this explainer, the curriculum leaves us with a final, thought-provoking question to chew on. As you continue to measure the waves in the world around you, from the music you're listening to right down to the light hitting your eyes, how will you use this expanding knowledge? Will you use your understanding of this complex creation to anchor your morality and make choices that bring lasting peace? Thank you so much for joining me for this explainer, and hey, keep exploring the amazing world around you.